All right. Hello, everyone. I'm Sujay Murthy here, working with the Cisco NSO application team. I have Jonas Krogel here from the Netrounds. He's a Netrounds technical product manager. We'll talk about the Cisco's Secure Agile Exchange with Netrounds as an active assurance. So, for the agenda, we'll walk through the Cisco Secure Agile Exchange solution along with the Cisco Agile Exchange component and the solution stack, followed by the Netrounds assurance tools and VNF validation solutions, which we are integrating as part of SAE right now. So what's the problem statement here, right? I mean, we see a lot of global enterprises have disparate user groups accessing applications hosted in data centers over MPLS or SD-WAN. Now, with the emergence of cloud, like SaaS-based offerings for Box or Office 365 and infrastructure as a service or IaaS offerings for AWS, Azure, or Google Cloud, the enterprises are leveraging this to move and host their applications in cloud. Now, this does poses problems to them on how do they have a centralized, repeatable architecture, which can help them ensure that the applications are hosted in a secure cloud and also giving them the visibility on traffic to monitor and access their policies. So the solution to this, one of the use case problems was the Cisco Secure Agile Exchange. It leverages the emergence of carrier neutral facilities or co-location centers as the points for multi-cloud access, which gives them a flexible architecture to connect to any of the cloud-hosted applications and also manage and configure the policies for each of their users. So the secure access to the multi-cloud is automated policy-based driven to support any third-party DNFs and any infrastructure needed to set up within the Secure Agile Exchange. So what does the Secure Agile Exchange stack looks like? We have identified them as the consumer zones where all your users, your devices can access any of the hosts or applications in the provider zones where they are hosted on your private data centers or any of the cloud services providers. And then in the between, you have the stack of the compute for the network function virtualization with the Nexus 9K switches and the orchestration platform on top of that. So to deep down, each stack consists of starting with the N9K, the Nexus 9K switch is the switching backbone infrastructure connected to the Cisco's cloud services platform, which is CSP hosting VNFs. And this could be like any of the Cisco's VNFs or third-party VNFs like Palo Alto, Fortinet, or F5 load balancers. Cisco's EAC is the VNF lifecycle management for managing the VNFs and deploying the day zero configurations. On top of that is the network service orchestrator running with the core function pack, which models and deploys the service chains to manage your infrastructure requirements like site-based requirements for resource pools, AS pools, etc., along with your full northbound API support to integrate with any of your existing OSS or BSS systems. So what does the solution stack here look like? We look at a per site basis where users can integrate with NSO, the nets, the CDB database, along with the APIs and the function packages loaded on the NSO for them to seamlessly deploy the service chains and manage any of the day one and day two configurations through this. We recommend one instance of SAE in HA pair, followed by one instance of the VNF lifecycle manager, that is ESC per site. And nets really give you the flexibility to enable the day two configuration from the NSO to deploy and manage any of the configurations through your service chain VNFs. We have an SAE Solution UI sitting on top of the NSO to provide a seamless user experience. And this is, I'll show that in the meantime in the demo. And the APIs are available for current or even users to integrate with any of their OSS systems. So what does the site infrastructure look like? We have the Nexus 9K switches in a VPC pair connected to your compute hosts in the infrastructure, followed by you have your NSO and ESE, along with the assurance from Netrounds Control Center to be spun up and readily available for you to deploy your services. So let's look at a typical deployment process. If you have your applications moving from your data center to cloud-hosted applications, what you typically look at is you identify what are your policies, what is your bandwidth, what are your traffic requirements to flow through the service chain. And then you would identify which VNFs you want these services or the service chains to deploy and instantiate, followed by you design your service chains based on whether you have HA or cluster requirements or CSR in ECMP-based traffic. Any of those service chain VNF characteristics is designed through your service chain. And then you can onboard your site, like what I showed in the previous topology where you have your infrastructure set up. You run your infra discovery through the core function pack to identify your connections between your compute host and the switching infrastructure. And you can use that topology connectivity to deploy these services. What I meant is instantiate a service chain. You instantiate the service chain from the UI, and it is seamless that once it is up and it is deployed for you, you can go ahead and see what NSO brings is those various allocations needed, the right bandwidth requirements, your VNFD constructs, or your NSD requirements to build into the service chain. But that's really not giving you the tests here. Like you would want to ensure that your service chain is fulfilling to your requirements. So what we integrate is with Netrounds to run some validation tests and see that it can meet your requirements for a production-based deployment, and it's the most reliable or your efficient service chain which you've desired to deploy in the service. So let's look at the current enterprise use cases. Like how do they access? We have a branch connecting to your applications and data center, and customers are moving their applications towards cloud. So you connect to the other service provider routers, you bring in the cloud applications, and your traffic typically has to pass through your data center because that is where your policy management and your firewalls are connected for you to access to any applications in the cloud. What it impacts is it increases the latency on your traffic, the bandwidth, and the tromboning or the hairpinning effect which is needed to enable the reverse traffic to come back to your data center. So as I've spoken before that, we would leverage the colocation centers application. So right now, if this is where your connectivity is, you're moving your cloud applications to the cloud and your connectivity from the branch. You spin up you have your colocation center, you have the infrastructure set up, you connect your gateway routers to these your data centers and your branch site, and all you do is you spin up your VNF instances in the compute host on the colocation center, where the traffic now would directly pass through your VNFs, maintaining you the service chain traffic policies and giving you the leverage to configure any access controls or management controls needed as part of your service chain deployment. Right, so this was an overview brief of SAE. I will walk through the demo to show how we do this right now. For example, I want to see that I have a San Jose site with my branch office connected to the gateway routers, and these are the handoff mechanism for me available at my site. Right, and I want to access my applications in AWS, which I know my handoff mechanism, the router connected to the application on the other side of the AWS routers. What I need to do is I need to spin up a service chain with a router connecting to these endpoint gateways and a firewall in between to manage and access my policies. So as I said that I can design this, I can identify the flows, I can define the bandwidth, whatever is the requirements, but eventually I would still need to test the traffic flow through the service chain. What I would do is I would also connect a Netrounds test agent, which would help me connect to each of the links on the service chain VNF and help me pass the traffic and validate that this is actually intended to what I need here. Right? So let me switch paints. I can show you the UI. All right. So this is the solution UI which I have running on the NSO to say that I have 3 sites, San Jose, Washington, and Texas. So my intent here is to deploy a site or a service chain in the San Jose site. So I would go to the service deployment page, and I would see that there are a bunch of connections. There are my endpoints which are connected in the site. And I need a connectivity between my San Jose to AWS application. What I would do is click on the end-to-end chains, name this site as San Jose to AWS, select my endpoints, that is San Jose is my first end, and the other end is the AWS. Now, I've defined my design, I've created the NSD, the catalogs required for the service chain instance. So I am going to reuse one of the Cloud Edge Assurance service, which my intent is to connect between the service chains. So if I click next, so this shows me that I have a service chain here intended to deploy between San Jose and AWS, and there is a test agent here connected to all the links in the service chain to between these 2 endpoints. So I draw a link between these 2 sites. So San Jose, I give this an IP address 42.42.42.2 and another IP address to the test agent. Save this. So I see a link which is now connected. I click another link from here to the AWS site and give this an IP address of 140.140.2 and another IP address to the test agent. Save this. If I need to attach any of the configuration parameters, like you have your licensing requirements to the VNF, you have your license auth codes, any of the VNF characteristics which you need to pass at the time of your deployment, I can define the parameters here. And finally, the bandwidth requirements on the service chain. The default for me right now is 512 Mbps, but I can pick the bandwidth requirements because that is where the orchestration will do and identify the NICs and the bandwidth required for each of the links on the VNF to connect it and attach to the CSP compute host. So I don't have any bandwidth requirements. Go ahead. The validate is the API call request which goes down from UI to the NSO. So this is the deployment payload request which I see right now coming from the UI to the NSO. Click OK. And we go ahead and deploy the service, right? So I've deployed the service from the UI. It is taking this request. It is processing here. In the meantime, what it is doing is NSO has received a request. It will process the placement and the functionalities for each of the VNFs. So once this shows up here, so I can click on this link. And see here, this is my site which I've just instantiated from the UI, the deployment payload request. And when I hover over each of the VNFs, this shows me the allocations done from the NSO for your BGP AS numbers, the VLAN IDs, the IP addresses, and from which resource pools it is being allocated to this service chain VNF, right? So this would take a couple of minutes, but I would really rather would like to show is something on the back end of the CLI, which is where we are more familiar with, right? So what we typically leverage here on the UI is the plan component of the service chain. So if I look at the plan component we have for a particular site, and so what it shows here is this deployment request is received by NSO. All the plan components from your NSD deployment, which shows it has 4 VNFs from the VM deployment states to all the initial placement image ready states to the VM deployed, and the required switch configuration on N9K is also passed as part of your plan status component for you to see for the service chain what component is really deployed and where the errors, if any, would show up on where the state has failed for you from the service. Right, so let me go back to the UI. So as this is deploying, I would show on one of my pre-deployed service chain, which is between a consumer 39 and provider 139, which shows that I have a service chain, similar typical service chain instantiated with the Netrounds test agent connected to the service chain. Now, I would like to see the monitoring on the Netrounds controller for the particular service chain, which is between consumer 39 and provider 139. I can see that there's a current monitoring happening on this service chain for the HTTP traffic, which tells me that what is the bandwidth at which the rate the service chain is catering to, and if there's an HTTP allowed access policy on the firewall to allow HTTP traffic right now through the service chain. So to walk through more on Netrounds, I'll hand it over to Jonas.
Okay, thank you very much. Okay, so why do we have Netrounds in this solution? Well, it's to validate that the service chain we spin up actually function as intended. And the Netrounds solution helps at all the stages of the NetDevOps process. So in the design phase, we help with testing if the network function functions as it should, so it has the right functionality and the right performance, and that other kind of traffic is not negatively impacted by deploying this function. So then when you deliver this service chain to your customers, for every single service chain that you spin up, we can do the same tests as we did in the design phase, validating that each chain is performing exactly as it should. And then during operations, we can work with monitoring the service chain to see if it's available 24/7 as it should, and if there is any degradation of the performance happening over time, and then provide alerts when this happens, of course. And then we have tools for troubleshooting service chains and VNFs, so identifying what component in the chain is faulty and what is the actual impact to data link traffic going through the chain. The architecture that makes this possible is we have the Cisco SAE, including the NSO, integrating with the Netrounds Control Center using our native NetConf API. This is also where we integrate other Cisco products like the Crosswork family. The Control Center has a dedicated web UI where you can see the current tests, the monitors, and also do configuration changes and also execute troubleshooting tasks. The Control Center orchestrates the Netrounds test agents, which are distributed in the network, either inside service chains or in various data centers or customer locations. The test agents run test traffic from one test agent to another one to simulate various kinds of applications and protocols, but they can also work as clients consuming external content for content servers, such as video streams, HTTP requests, DNS lookups, doing zip calls, and so on. So just like a normal end user would. And they can also do reflection measurements towards a router or a CP, for example, using TVAM or even basic UDP and ICMP echo. So how do we apply this to a VNF world? Well, the classical approach to test a virtual firewall, like in this example, you have a firewall between the branch office and the remote WAN. So you could place a client on the customer side and a server on the WAN-facing side and simply run traffic through the firewall. But this comes with a few different problems. You need to synchronize the clocks on the client and server to have accurate measurements, And yeah, it doesn't scale very well. It consumes more resources than our approach. So our approach for virtual appliances is to use a single test agent appliance running in the same hypervisor or same compute data center and attach it both to the inside and outside of the virtual firewall and run traffic from one interface to the other one. And this is possible because we implement network namespacing, where each interface has its own routing table and its own default gateways. So this gives us extremely high accuracy, and we know exactly that the only thing between these two interfaces is that component. This also comes with the benefit of scaling. So when you build a chain consisting of many VNFs in a sequence like this, here we have a router, an IPS, and a firewall all chained together. You can take a single test agent, give it 4 network interface cards, and connect them into the link network between the VNFs. And to get a complete picture of the end user's perspective on the service, you can run traffic from the inside to the very outside of the service chain, and you get the full chain performance. But then you can also, by cleverly selecting the interface and destination IP address, only traverse a single VNF with the same kind of traffic. And by doing this one at a time, you can sectionalize what is the performance per hop in the service chain. And this is really a unique approach that provides great benefits for troubleshooting. So let's look at how this is visualized in the Netrounds GUI. So this is a screenshot of how a service chain monitor would typically be built. In the top bar, you're seeing a base test traffic going through the full chain, so traversing VNF 1, 2, and 3 in order. And we're measuring latency here, and we're seeing that latency is about 5 milliseconds in one direction, and we have some amount of packet loss on average. The bar is representing the past 15 minutes of time, so this is quite real time. And green means that all traffic is meeting KPIs, so we don't have any problems, but black and red means that there is some problem. In this case, the packet loss and the delay is the problem. Below this, you're seeing the VNF number 3 and the VNF number 2. So this is test traffic only going through that single VNF. And you can clearly see that VNF number 3 does not have any problem. But VNF number 2 has problems at the same time as the end-to-end traffic has problems. So that's likely the root cause. So it's very easy to correlate and figure out what VNF is the faulty one. And of course, you can click on them to get more details and historical data. So this is again the 15-minute visualization of latency and packet loss for the full chain. You can click on the firewall. We're looking at the VNF number 3 now. And here we're seeing that it's all green and the latency is 0.06 milliseconds, so 60 microseconds. Extremely high resolution, and we can clearly see that that one is functioning perfectly. But when we go to VNF number 2, this one has the same look as the end-to-end performance. It breaks at the exact same time, and it impacts the latency with about 50 milliseconds, about every 8 or 9 minutes. So clearly that is the problem with this in the service chain. So expanding this into monitoring the end-to-end perspective in the network, we could spin up an additional test agent in Amazon Web Services or another cloud or compute platform, and we could run tests from our service chain test agent to that remote test agent to test the end-to-end performance. And for sites where it's not feasible to deploy test agents, for some reason we can work with reflection measurements to complement that and give the last mile perspective of the network using reflection measurements like TMAP. So that's perfect to talk to a customer CE or a router that doesn't have app hosting capabilities. So now we're getting the first part of the network for the customer. We're getting each section of the service chain monitored, and then we're getting the other section to reaching the cloud or the remote service in a fifth perspective. So we can clearly see if it's a local problem, searching problem, or bad problem. So what kind of tests do we actually do? So this is an overview of the toolbox that the Netrounds Solution provides for validating various Netrounds functions, but I don't have time to go into all of these today. So I've highlighted the ones that is mostly relevant for validating VNFs. So when you spin up a VNF, these are the tests that we typically would advise you to run. So you would do M2 discovery, looking for M2 mismatch configuration problems. do a TCP throughput measurement to see what is the total maximum bandwidth you have through it, either in a single session or a multi-session setup. Measure the basic one-way delay variation, and packet loss. Checking for open ports, that the right TCP and UDP ports are open that should be open. Check that they have the right TCP remappings and QoS behavior. Do synthetic voice calls to make sure that voice traffic is not negatively impacted. Do a path trace to document the routing for traffic traversing the service chain. And is it possible to access internet services, like doing HTTP requests, DNS lookups, and so on. And then, of course, measuring the gateway latency, jitter, and packet loss to see the network section performance. This is an example of how a sequence in Netrounds could look like. So everything is done in sequence. So we start with doing one test. We see if that is okay or not. Then we do the next test, and then the next one. So in this case, we're starting with a path MTU discovery. We're looking for an MTU of at least 1460. And after that, we go on into scanning for the ports that should be open, that they are open. So we're checking that port 2280 and 443 and 8080 is actually reachable through this firewall. Then we're doing a QoS test where we load that VNF with 50 megabit of TCP traffic bidirectionally, while at the same time we set up 10 concurrent voice calls and make sure that the voice quality is not degraded while we are loading it with TCP traffic. So this is a parallel test going on here. And then we're testing that we can reach our internet services. We're doing repeated DNS lookups of a few different domain names, and then we're doing HTTP requests to websites and measure the page load time to make sure that the internet performance is still performing as it should. And lastly, in this case, we're documenting the routing taking place by doing a path trace to the Google DNS servers to document the routing, so that later on, if you want to see if the routing was actually correct when we deployed it, you can look at the result from this path trace. How this could look like in a real scenario, this is the result of a validation that we have done for a single VNF running. We can see that the path MTU discovery was successful. We see that by the green bar. So that means that it was passing the set KPIs. And the same for open ports, also okay. QoS was okay. But we have a red mark on the internet services indicating that something was not as expected with reaching internet through this VNF. So by clicking on this one, we get details for all of these tasks that was executed. And we can see that, oh, almost everything is green, except for just resolving Netrounds.com. It actually failed for 1 second. So the initial 1 second when doing this did not meet the KPIs, because I put in a KPI of 50 milliseconds in resolution time, and probably this domain name was not cached in the resolver being used here. I could decide that this is still okay. I understand why this is the problem. I can go ahead and still launch the service to the customer. And then, of course, you can click on it to go into granular details on exactly what was the performance over time during this test. And you have access to the full logs and full KPIs over time. So that's very briefly how we could validate a DNF using a sequence test. Okay, so just handing back to Jay for some closings.
Sure. Thank you, Jonas. So, in summary, what we see with Secure Agile Exchange and Netrounds is the partner for Cisco to do our assurance tests. The Secure Agile Exchange really enables a multi-cloud journey for customers. Right? What we see is customers can capitalize on the transformation in the consumption model, and also it has the ability to offer new services and business models, programmable, customizable, and extensible to fit into any existing OSS and BSS stack. And with the built-in active service assurance using Netrounds for each VNS, in the service chain, the validation of the service chain is really helpful to kickstart this journey. Right? So, thank you very much for listening.